3D printing is used across many industries, from engineering to manufacturing, dental, healthcare, jewelry, and more. The technology offers a wide range of applications, from visual and functional prototypes to end-use parts. There are many 3D printing solutions on the market. Each one has its own benefits and limitations that make it more suitable for certain applications than others. To help you identify the solution that best matches your requirements, we'll be comparing functional and visual characteristics of 3 of the most common 3D printing technologies for plastics: FDM, SLA, and SLS. Choosing the technology and material with the right functional properties is crucial to make sure that your parts will work as designed. Starting with build dimensions. Most common FDM printers offer around 200mm cube-sized build volume, with large format options going as big as 300 by 300 by 600mm size. Like with FDM, professional desktop SLA printers can come in standard or large format models, with most standard sizes being around 200mm cube size, and large format models offering a 5 to 10 times bigger build volume. The build volume of benchtop SLS printers is comparable to standard FDM and SLA printers. The next thing to consider when it comes to functional properties is tolerances. If your parts require tighter tolerances and higher accuracy, SLA and SLS are your best options. Both technologies use highly precise lasers to form each layer with reliable and repeatable results. Moving on to material properties, FDM and SLA both offer a wide range of materials with properties comparable to common injection molded plastics. Material selection for SLS is more limited, but this technology is the best choice for durable end-use parts. SLS nylon parts also have great heat and chemical resistance. FDM 3D printers use thermoplastic filaments, such as ABS, PLA, and various blends. SLA printers create plastic parts from a variety of thermoset resins, each formulated to match the characteristics of common plastics. SLA 3D printers offer the most flexibility, literally, with both flexible and soft silicone-like materials. SLA also offers the material with the highest heat deflection temperature of 238 degrees Celsius. SLA printers provide the widest selection of biocompatible materials for dental and medical applications as well. The most common material for SLS 3D printers is nylon, a highly capable engineering thermoplastic. Desktop plastic 3D printers can also be used to create metal parts by casting 3D printed patterns. SLA is a go-to technology for 3D printed castable patterns for jewelry, dentistry, and engineering applications, while FDM also offers some more experimental options. In case you have specific requirements in terms of strength, stiffness, elongation, durability, or other properties, we recommend looking at technical data sheets. For applications like concept, artistic, or sales models, and looks like prototypes, you should select a technology based on appearance and visual characteristics. In FDM 3D printing, coarse layers are extruded by a nozzle, which lacks the control and ability to achieve the level of details that the other two technologies can offer. That's why FDM prints tend to have clearly visible layers. Thanks to the highly precise lasers, SLA and SLS are the gold standard for producing high-quality parts and models with intricate details and fine features. In SLA, the laser controls the light with high precision, and each layer takes a parabolic cylinder shape that aligns better with the previous layer. This creates a smoother surface finish right out of the printer with reduced staircase effects, especially for overhanging and upright geometries. SLA is the gold standard for producing high-quality parts and models with intricate details and fine features. SLS printers also use lasers to achieve highly detailed printed parts, but because lasers work by sintering a powdered material, parts come out of the printer with a slightly rough, grainy surface. "3D printed parts can also be sanded, polished, primed, and painted to achieve the desired finish. Post-processing SLS parts is the easiest because there are no printed supports to remove from the printed parts. SLA parts require some sanding to remove support marks when printed on supports, while FDM parts need substantially more sanding and polishing before priming and painting for a high-quality finish. FDM materials are available in a wide variety of colors, while some SLA resins can be mixed with color pigments to match almost any custom color. Lastly, SLA has the unique capability to create transparent or even optically clear parts. SLS parts can be dyed to achieve different colors. FDM, SLA, and SLS 3D printing offer many materials and options to best match the functional and visual requirements of your application. In many cases, it can easily happen that 2 or even all 3 of the technologies are a good fit, in which case it's your call to prioritize your requirements and weigh other considerations like speed, cost, workflow, or ease of use.